right, let's check out this recursive question here. So we can see that it is not arithmetic because it's not going up by equal increments. Let's check it and see if it's a geometric. So to see if it's geometric, you would take 24 divided by 16, 36 divided by 24. And it looks like it is a geometric because when we take 24 and divide it by 16, we get 1.5. When we take 36 divided by 24, we also get 1.5. So that's a good thing. All right, so next we can use the geometric formula for sequences here. However, let's check it out in terms of recursion. So what we were seeing here is that when we divide by 24 by 16, we get 1.5. Same with 36 divided by 24, we get 1.5. That means if we multiply 16 by 1.5, we should get 24. And same with if we multiply 24 by 1.5, we should get 36, and so on. So then we should be able to find the next two values here. Let's go do that. What was that, 81? 81 times 1.5, that gives us 121.5. So that's our next one. And you can find the next one there by multiplying this by 1.5. Okay, so in terms of recursion, the easiest way to do this is to put the t's on top. So this would be like your first term, your second term, your third term, your fourth term. We kind of want to define them. We know for recursion, we always have to define the first term. So the first term is 16, and we're going to use 16 within our next formula in order to get the next term. So in order to get the next term, which is T2, we would take the previous term, T1, and multiply it by 1.5. That's what recursion means. Recursion means to take from what you already have and then add on to it. Right. Same if we wanted to find T3. For T3, we would take T2 and multiply it by 1.5 to get the next term. Same with T4. T4, we would take T3, so take our third term and multiply it by 1.5 to get the next term. Right, here we could see that these are all larger, 1 by 1, so it's 4, 3, 2, 1. This is 3, 2, 1. This is one larger on this side, so we have a larger n on this side. And here we have a smaller n value by 1. Or we can say n minus 1. There we go. So our recursion formula, Tn is equal to, so this just means our general term is 1 less than the n value here times 1.5. So there's our recursion formula. We also have to have T1 defined because we can't throw a 1 in here because 1 minus 1 is 0, and there's no T zeros. So that's why we define the first term, and then we kind of figure out from there what our next terms are. Hopefully that helped.